Hello everyone, this is Mr. 13 Things coming at you now, talking a little bit about putting some of the pieces together of technology, if you call a really old calculator technology, and basic hand calcs, and more importantly, this concept of when we start introducing some of the real basic concepts of calculus. My argument is, of course, around 5th and 6th grade, but we'll be okay with 7th and 8th, especially with when it comes with regard to the differentiation of a function or the slope. So let's go ahead and just kind of get started first with the basic calculator. We're looking at a TI83 plus here, TI84, they all run about the same. Except for the amount of memory. It's the programming language you're interested in. But first thing I want to start off is this is a basic tool. Best practices would have it, I would guess, for me starting around 5th, 6th grade, 7th or 8th, I guess will work for that. And then recurrent and repetitive use in lots of different classes. So math is no longer this scatty thing off on the side. So first thing we want to do with any machine is ask it a question you know the answer to. And one of those questions I think you might know, if you know what the basics of tangent is, what's the tangent of 45? You plug that in, you get the wrong answer. Why is that? The first thing you should do with any machine is learn how to ask it a couple of questions you know the answer to, and then know how to change the settings or have them set so you are actually calibrating the machine each and every time you need to. In this case, you go to mode. And you notice because the standard of mathematics, and this is a good standard, is the radian, it is set as the radian. But for now, we'll go ahead and click down and set that to be degree. The concept of not having, infinite number of decimal points or a few decimal points depending on what you want to do. You want to set that right away to some bit. The rest of these you'll see later, whether you want to be dealing with just real numbers or imaginary numbers, etc. So the big thing here is to put it to degrees, probably until everyone gets it in their heads that radians are not scatty and we should be using them. So you hit enter here and hit second quit. And now when you say what is the tangent of 45, you get the answer. It is not don't touch the settings, in my opinion. Someone will always touch the settings, and in engineering work or science work, that's where it leads to problems. So that said, the other thing that we're going to start talking about is setting up of graphing. And of course, the big thing you want to often do with these things is make sure that your x and your y axes, or the abscissa and ordinate, are set to the same scale until you do it otherwise, so you can start to recognize shapes as being shapes. Later on, you're going to see you'll want to draw a shape that you know the shape of, typically a circle, and make sure it comes out to be a circle. But basically, one of the functions you should know is y equals x. And what's great about this little calculator is it kind of knows what form you're in or what kind of system you're in, whether you're in polar notation or rectangular coordinates. So you just basically type in x here, hit an enter, and now if you say graph, you see that, and you see that that does not look like a 45-degree line. Therefore, you are starting to untrust what you're supposed to know, which is what is the tangent of 45 degrees. The way you go about fixing that at any one point in time is going to change, but basically I think the easiest is to go to zoom square. Now that is a 45-degree line. Now the next thing you might want to do is learn to grab other functions, and we're going to go down to there. I down-clicked with my down arrow on the computer. I am now going to do another function that we should very quickly know how to do, and that is x, learning how to use the caret, x squared, and then going ahead and graphing it. And there you see the function x squared. Very quickly, what you also start to do is want to basically learn to play around and not just pre-calc, but go down and maybe instead of making x squared, making it 3. Hold on. That should be, I'm hitting x here. I'm going to go down to here, going down with my key. Interesting, I can't do that. X, hit an enter here, and I am going to, with 3, x squared. And graph that. And if I go ahead and make another one, I'm going to go ahead and once again I'm hitting here and then x squared. What's the downside of this? No colors. That's why I will never show the TI83 calculator without doing a promotion of the Apple Grapher, hopefully the original Apple Grapher, but anything or GeoGebra or Geometer Sketchpad. Apple Grapher, of course, has 3 and 4 dimensions, which is what our kids are dealing with. So we're going to hit graph there, and you start to see you can't remember which is which. But what does it do is you add greater and greater numbers. I'll go ahead and change one more. So this is less. The wider you make this. We'll try one more. We'll try 100. And now we're in the order of the parabolas that many of us see every day when we do things like drive our cars. So learning how to graph, but more importantly, how to really control your axis so you can start to trust your eye. And so 100 makes it really, really basically closer to a line up and down. So what would be the opposite of that? What could you change? Maybe basically here, you could change that to 0.01. Did that wrong. Going back here. But it didn't like that. .01. Doesn't like that. I have no idea what that's doing there, but go over here. 0.01. Does not like what I'm doing here, so I'm going to do it though. I shouldn't be using. What I should be using is I'm going to hit here, go back, hit the space bar, so it should work. This is acting a little bit weird, but I'll keep going and finish this one out. So hit the clear button. I like to hit second quit. It must be the insert versus non-insert we're looking at here. So we are once again going to go to Y here. We're going to go down, down, down. And in fact, clicking over here, entering, over here, entering, and that's not going to work. Okay, such as it is, learning how to play around with technology here can be a good or a bad thing. What I want to point out is, in fact, all the settings on the window are then set here. And later on, teaching students that something's going on in terms of an aspect ratio will help them to make these ratio correct. You notice here the ratio is 1.516 to 1. That's the difference between the scale and the X and the Y. We got that, if you remember, second quit, by using zoom square. And then starting to zoom in and zoom out. Zoom square got us to the point where that was a square. All right, that said, now let's explain how one thing you might want to teach students earlier more than later, and that is the calculus. So the calculus of a very simple function, let's look at the function of x squared. So many students will know that they can write an equation, hopefully y equals ax squared plus bx plus c. So when they see an equation y equals x squared, they should in their brains think that's 1x squared plus 0x plus 0. So those who grab to what a lot of students really like to think is they have understanding of quadratic equations because they can solve for the roots, and they know that the root is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. But that doesn't tell them much about the shape. It just tells them where, in fact, this parabola crosses the the x-axis. So that said, one thing that will all, and actually many they'll be smart enough to know that it'll also tell them that the vertex is halfway in between. They should be able to figure that out pretty quick, unless this thing is twisted. I think when I think about it, it's going to always tend to be, the vertex is going to be halfway between these two. We'll have to think about that. However, let's look at the differential here. The differential of y equals 1x squared, what you want to do is you want to do a y prime. In other words, the slope of the function is going to vary, and that slope of that function equals 2x. You set the function, the slope, or the derivative equal to 0, and you solve for it. In that case, x equals 0, which tells you where, in fact, is the minimum or maximum of the function. That's all well and good, easily done. Do it one more time here, but this time we're going to go ahead and hit cut. Let's do another function. Go ahead and say y equals 3x to the second power plus 7x plus 4. Now, of course, the students can then solve for all kinds of things, but let's just figure out where is the vertex. Later on, they're going to know that this is actually, I think, with its mouth to the top, and they're going to learn how to use something called complete the square and get it into a format of y equals x minus h squared, some sort of a out here, plus k. That's all well and good, but they can also figure out the vertex this way by taking the derivative. In other words, the slope of y, changing y with respect to x, y prime, whatever you want to tell them, the slope, and they're going to make this as 2 times 3 or 6x plus 7, and they're going to set that equal to 0. Set equal to 0. So now they have a reason why they're solving sometimes for those roots. 0 equals 6x plus 7. 7 minus 7 equals 6x. And x equals minus 7/6. This becomes the point where this function has its relative minimum or maximum, as the case may be. They now can go into the roots to figure out where it does cross, and the roots in this case would be a minus b, so a minus 7 plus or minus the square root of 7 squared minus 2ac, 2 times 3 times 4, all over 2a. 2a, of course, being all over 2 times 3. They can solve that, and now they, in fact, know where it crosses the axis. They also know the x value of the vertex, and they can plug that x value in to get the what the y value of the absolute vertex is. Now, that said, my question would be, once they know how to do that and start to understand why they have all these different forms and what it can do, unless they understand truly that a parabola is a conic section, a lot of the rest of this, we cannot run away from our technology. So we have here, let's go ahead and do it in graphics. So we said the equation was 3 times x squared plus 7x plus 4. These other ones I'm going to go ahead and see if I can delete and delete. And we can now graph that, and we can see that, in fact, and we can now zoom in. I think it keeps it square when we do that. Zoom in. Zoom in. Zoom in. Okay, it's showing us, it's kind of hard to see what's going on with this, but we know that the x is at minus 7th x. We should know, let's see, this is 49, so it's minus 7 plus or minus 1 all over 6. So it is pretty close to what we're talking about here. So this, if we solve this, we have 49 minus 2 times 6, that's 49 minus 6 times 4, 24, which is 5, so minus 7 plus or minus 5 all over 6. This is minus 7, so this is minus 2 or minus 1/3. And if you remember, we're talking about this might be right in the middle of the two. And if we go back to the calculator here, unfortunately, zoom in again, zoom in again, you start to, oh, we don't really like that. Well, we can also go to the window here and tell it clear. We want our x minimum to be -2. Our x maximum, oh, don't want to do that. We want our window to be x -2. Remember, use the minus here, not the minus there. We want the x maximum to be 2. Now, again, you'd like this scale in the y, or the y minimum, to be different than the x minimum, but I'm not going to do that here. From -2 is for the minimum, and this is 2 for the maximum. And now when we hit graph, we can see that it in fact does cross there. Now, realistically, that value, the ratio, this is supposed to be 1.5 times as much, so we should probably make that -3 if we're being good to the students from day one, so they can learn to put things and not let the computer tell them what their scales are. And then when we hit graph, we get pretty much the same thing. Let's happen when we say zoom square here. Right, so that doesn't help so much. So that fact of getting this window and having the set of, and it looks like it did do it for us, this window set up so we have a perfectly square or true x and y scale is a great thing. All right, so that's a long-winded explanation of just running you really quickly through what I want you to remember. If you're using a calculator, always, when you turn it on, ask it a question you know the answer to, and that would be the tangent of 45, or eventually the tangent of pi/4. You also might want to ask it even a question that you don't understand, but what in fact is e, open parentheses, I, second I, and second pi? Ask it that question, e to the I pi. Oh, it seemed to give you something that kind of made sort of sense, even though this number here looks a little odd to you. But basically this is -1. So if you plug those two things in, that's not necessarily correct, because the e to the I pi should not make any sense unless you go ahead and change back to the mode and change it to radians, second quit, and then once again hit equals e to the I pi, second e, open parentheses, second I, and then second pi. Still gives us the same answer, which is interesting because we should have it set to, right, degrees. So you want to check that. That's a way to remind yourself that the mode should be set the way you want the mode to be. The other thing you want to remember is, in fact, set your scales. Be very cognizant of what your scales are set to be. And then on the calculus end, understanding that if you take the first derivative of a function and set it to 0, it will tell you where that function has a 0 slope, or is at a relative maximum, minimum, or at a point of inflection. So those things are all convoluted in here, but understanding that jumping back and forth between different tools is a way to ensure some sort of redundancy of learning and redundancy of thought and troubleshooting. Triangulation, if you would. Thanks for listening.